Welcome to Let's Talk Micro. Hello, everyone. Welcome to the first episode of 2023 of Let's Talk Micro. I hope all of you had a nice break, a nice holiday, some good time off, a nice time off if you ended up taking time off. I know I took a few days off, but I also work and I was very busy at the hospital. So if you ended up taking some time off to spend it with family, friends, I definitely hope you enjoyed it. It's definitely great to be back here talking to all of you. As always, thank you for the support. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Google Podcasts, Amazon Music, Stitcher, TuneIn Radio, Pandora, Overcast, Good Pods. Whatever you listen to your podcast, you can find Let's Talk Micro. As far as social media, I am on Twitter as Let's Talk Micro 1, on Instagram as Let's Talk Micro no apostrophe, on TikTok as Let's Talk Micro, and on LinkedIn as Luis Plaza. So go ahead and subscribe to the podcast and follow me on social media. On social media, I always like to post pictures of organisms and give updates as to when the next episode is coming out. And of course, as you subscribe to the podcast and you download episodes, go ahead and leave a review. If your platform, if the application that you use allows you to leave a review, go ahead and do so. Like Apple Podcasts, for example, it allows you. I know Spotify lets you rate the episodes. So if you're able to leave a review, go ahead and do so. If not, at least rate it. And on social media and on email, letstalkmicro@outlook.com, any feedback, any suggestions, any podcast topics, go ahead and leave them. Anything is always welcome and appreciated. So definitely so many topics to talk about. And those of you that listen, because of the organisms and the biochemicals and the reactions, stay tuned. I'm definitely going to be bringing in more episodes about that. But this episode is going to be it's an interview episode, but it's about a test. And these two guests, I definitely know them. And I'm not going to mention it in this podcast, but definitely my employer at times, has been mentioned in interviews that I have given. So as always, I like to post a disclaimer that my employer has no affiliation to this podcast, so no affiliation to Let's Talk Micro. But the two guests that are in this episode, I know them and I have worked with them. And they come to the podcast to talk about a test that was developed. And this was a PCR test that detects 3 different types of amoeba. Those of you that are microbiologists, you're familiar with amoeba. They are protozoa and they are free living. Those of us that live in states where you have warm bodies of water, you're definitely familiar with amoeba. And of course, cases of amoeba, if you compare them with all the bacterial cases that as microbiologists we see, and as also with viruses, if we compare the amoeba cases, it's not seen as often. However, most cases end up being fatal. If they're untreated, they end up being fatal. So the 3 amoebas that the test can detect, they belong to the genera Naegleria, Acanthamoeba, and Balamuthia. And one day I will do an episode about amoeba. So Naegleria fowleri, which is a species that has been isolated in cases of primary amebic meningoencephalitis, is the one that we tend to be more familiar with. The person gets it when exposed to fresh water, and there are many challenges as far as detecting it in the lab. One of them is training personnel to identify it. Because, as I mentioned, we don't see it as often, so it's not like with bacteria that we can train microbiologists in the lab to recognize, let's say, E. coli, Klebsiella, that we see many, we subculture it to plates, we see it, we show it to text, we make slides, we do gram stains. So this is not seen as often. So getting good samples in the lab so we can show text to recognize it, it's definitely challenging. And plus, of course, those of you that work in microbiology, a lot of times, like large labs, they tend to be compartmentalized. And as the shifts go, like second and third shift, the training is not the same. A lot of the plate reading, the slide reading, it tends to happen on first shift. Everyone should be trained the same, but there are many challenges and many logistics, unfortunately, to getting that in place. So in summary, Since you don't have that many cases, it is not seen as often. It is hard to train the techs to recognize it in the lab, and at the same time, not many labs bring tests to identify it, especially a test like the one that this episode is about. But one thing is essential, which is identifying it, because cases of PAM, which is primary amoebic meningoencephalitis, they are fatal if untreated, and typically death occurs 3 to 7 days after the onset of symptoms. So in this episode, Dr. Jose Alexander, who's a microbiologist and director at AdvenHealth, and Dustin Evans, which is a microbiology laboratory supervisor, they joined the podcast to talk about this PCR test, like how it was developed, how it compares to similar tests, and more. So let's go ahead and listen to this interview. So on today's episode, instead of talking about bacteria, we are talking about amoeba. And today I get to do it with two microbiologists from Florida. There's this article about a PCR for amoeba that was developed in a microbiology laboratory. So with me today, I have two guests, Dr. Jose Alexander and Dustin Evans. Dr. Alexander and Dustin, welcome to Let's Talk Micro.
Thank you, Louis. Happy to be here.
Thank you, Louis.
Definitely my pleasure. So let's go ahead and start with an introduction for the audience, please.
All right. My name's Dustin Evans. I'm one of the lab coordinators at microbiology at AdvenHealth Orlando.
So I'm Dr. Jose Alexander. I'm the medical microbiologist and medical director for the microbiology laboratory, also at AdvenHealth Orlando.
All right. So once again, thank you for your time. So let's go ahead and start just for the audience for a brief overview of, the test says that, it screens for 3 amoebas. So can you start with an overview of these? For example, like how do you acquire them, symptoms, spectrum of disease?
Sure. So there is multiple free living amoebas, but there are 3 of them. There are the one that are known that can infect human as what we call an accidental host. So the typical one is, the most common one is Naegleria fowleri. This is a Naegleria that probably represents 95% of all the cases that we have seen in the United States. They live in warm body of water, as lakes, rivers. They are common in the southern states, but now that we have cases that have been seen on the north. These Naegleria normally infect humans, invading to the brain through to the nose. It's able to penetrate to the base of the skull and reach the brain and create symptoms similar to meningitis, with a fast evolution and also with severe symptoms. So one of the difficult situation with this syndrome is that the reaction of the immune system actually create this severe reaction in the brain. That is what causes all the symptoms and the rapid progression of the disease. So the other 2 amoebas that we are able to identify is Balamuthia mandrillaris. Cases of Balamuthia is a little bit less common. It's just very few in the United States. And Acanthamoeba. Acanthamoeba species, another free-living amoeba, but it's more related to eye infection, especially with contact lenses. So all these 3 amoeba is able, based on the test that we develop in AdvenHealth, are able to be identified directly from CSF.
Okay. Yeah, thank you for that. And I think generally, even the public, for the most part, even outside of the microbiology and the science field, maybe they might be a little bit familiar with Naegleria. Sometimes, when they do like any medical show, maybe that's the one that they do present on those cases. So maybe everyone might be somewhat familiar with it. Okay, so in the lab, normally, how do you screen and test for amoeba?
Typically, in the past, we've used wet mounts, using microscopy, using a wet mount, trichrome staining. The trichrome staining can stain the amoebas, and the wet mount, you're looking for a motion. You're looking for an amoeba that is moving around within the solution.
Yeah, that was a test that we used previously. So Dustin team has been working with this test for a while. That was probably our initial approach to be able to detect amoeba from CSF. So we take advantage of the movement of the amoeba, put the CSF in a warm condition environment, normally in the incubator for a few minutes, and then put in the microscope, and we're trying to see the movement. One of the issues with that test is that some of the white blood cells chemotaxis, the way that they move, can mimic the way of amoeba sometimes move. So expertise is important, but since this test is very, very uncommon, it's really difficult to build expertise or skills. So that was a test that we've been using. To reinforce that, we also use a trichrome stain. That's a stain that is used in microbiology to stain parasites. And we use these to stain two different techniques together to trying to identify the amoeba. Normally take hours, if not a whole day. Luckily, we use this test for maybe over 5 years. We never have a positive or any discrepancy with any of the clinical cases. That's one of the reasons why we also moved to have a molecular diagnosis.
Yeah, and also with microscopy, it's not very specific, so you're not sure which organism you're seeing, and it's not as sensitive because it only takes a few organisms to cause infection.
Okay, yeah, and definitely you don't get that test that often. So yes, like Dr. Alexander mentioned about the expertise, and so training the staff, it has to be one of the challenges for that. And sometimes, one of these things that the way that they happen, like normally this unusual test, sometimes, they happen at the most unusual hours, and you don't have the properly trained personnel. So that's one of the challenges in the lab. So you kind of touch about implemented, what led you to implement this test in the lab. I mean, anything else about that? Why just bring it in-house? Why just make your own test?
Because of the serious nature with this disease and the how fast it progresses and can lead to fatalities, we thought it would be important to bring on rapid detection by PCR.
Okay, yes, definitely, I agree with that. And not only, and we're in a state, yeah, with definitely plenty of warm bodies of water, so it's definitely something very useful to have in a state, in a laboratory in a state like this. So just for the audience, if another hospital wanted to implement this or had an idea like this, so where would they start, like as far as materials, etc.?
Well, the test is the implementation and validation can be a little bit challenging, but it's not really as difficult as it looks like. Instrumentation is critical. We use the platform by Luminex called Aries because it's practical from the perspective of performing the test. The reagents can be acquired for other companies. Some of the reagents come directly from Luminex. The validation process is a lab developed test. That's a process that is a little more time consuming, more specimen. We need to have more data and being able to do different statistic analysis at the end to have the test approved. And as all technical validation, we need to make sure that we accomplish a good statistic approach, right? With sensitivity, specificity, what is the minimum amount of amoebas that we can identify. All that have to be very, very clear, well specified. So any laboratory, they have the capability to build the instrument and have a little bit of the expertise with lab developed tests. We'll be able to develop this test in-house. It's something that can take time. You need to have some expertise on laboratory testing, but also in molecular diagnosis. So this is how the way that the test was developed, and this is a process that other hospitals can actually replicate.
Okay. Yes. Okay. So as far as the turnaround time, sorry. So how long does it take to obtain a result for this test?
So the test itself, once it's started, takes about 2 hours to run the PCR. It also takes the sample preparation could take 30 to 40 minutes. Quality controls are run with each patient test sample that we run, and those are frozen, so those must be thawed and then diluted. And each amoeba organism is run in tandem with the patient testing. So overall, it could take up to 3 hours.
So that's definitely that's very quick, yeah, considering. So once they provide the sample in 3 hours. Okay. So as far as doing the validation, and the implementation, so what worked well and what didn't?
Yeah, the validation was challenging. It was difficult to obtain actual positive patient samples due to the rarity of the disease. So we were able to obtain one positive CSF sample with Naegleria, and that was all that we were able to get. So basically, the whole validation was done using controlled materials.
Yeah, that's one of the challenge with rare diseases, especially infection disease, when we don't have access to enough sample. And this is also the reason why you probably don't see these tests being implemented across clinical trials to have FDA approved, because the amount of specimen available are so rare. The amount of samples required for a clinical trial is high. So that's one of the issues why it's really difficult to find these tests available in the market. So using different quality control, different standards, concentration, as part of the validation, from the detection of the low limit of detection, the setup of what is the minimum amount of amoebas that we can identify, then make sure that we are able to replicate that concentration, being able to set up the CSF from patients that we obtain for other culture, for other type of tests, being able to spike those CSF with the amoebas to trying to replicate the nature of the human sample that we want to be receiving. Also, the important is to make sure to know that if in that CSF, if there is any potential interference that can produce a fail of a false positive or false negative result on the test, so it's critical. Make sure that if a patient also have a co-infection with a virus, let's say herpes simplex, enterovirus, or even a meningitis for a Neisseria or streptococcus, make sure that if that is a co-infection, these other organisms are not going to be interfering with the amoeba PCR.
Okay, and I know that another challenge, because I was reading, right, that you started doing the research in 2019, and as we all know, in the 2020 we had this event called COVID, so that was definitely a challenge. So you had to kind of slow down, right, while you were validating this test.
Yes, yeah, we had to reprioritize testing for COVID as there were not many platforms for that test as well. So a lot of our validation focus for since 2020, 2021, all was focusing on COVID testing.
Yeah, we definitely had to adapt in many ways. So as far as this, this PCR test, so how does it compare to other PCR tests for amoeba? I know like the CDC has one. I mean, is that the only place that you will send it for testing?
The CDC have a PCR test that is specific for Naegleria fowleri. We don't have the specification what type of reagent or platform do they use. So there is, I will say, many different approaches for the PCR. The CDC, this is a communicable disease, a suspected case with all the epidemiological criteria of what exposure need to be notified to the CDC. So traditionally, the CDC have to review the case, and they authorize or recommend the use of the PCR in their facility. So the specimen has to be sent over the CDC for testing. This is a process that we still need to do clinically if we have a potential case in our facility, with the advantage that since we have the test in-house, we can also receive an aliquot of the CSF and do the test in a few hours when the test is ongoing or still in discussion with the CDC. There is some other facilities that are being able to implement some PCR locally. Most of them are probably academic centers, and some of them probably for clinical sample, for human sample, but also probably for environmental samples. So the advantage that we see with our test, especially in our region, being in Central Florida, is that we are probably a few hours away from multiple major hospital around Florida, and even the southeast of the state, I would say North Carolina and the south of Georgia. Some of the specimen can arrive here in courier in just a few hours, and in approximately 5-hour turnaround time, we can have a result back. So if we compare that with one 24-hour, probably 48 hours or more that we send to the CDC, that's probably, this still has to occur because that's part of the process that the CDC require as part of the requirement for diagnosis. But we can provide a preliminary rapid result that could be as accurate as the one provided by the CDC.
Okay, yes, and definitely time is essential on this because there are not that many cases, but most of them, when they are fatal. So having that proximity, like you mentioned, some adjoining states too, that they can send their sample in a few hours, we can start running it. That's very beneficial, for the patient. So is there anything else that you want to add about this test or anything?
Well, you mentioned something important, that is the time. So the disease advance, the whole syndrome advance pretty fast. It's normally some cases can be fatal in maybe week and a half. So the rapid diagnostic will allow clinician to improve the management. I mean, now it's a targeted treatment. There is very limited treatment available. There is a limited protocols available for these patients. Some of these patients require assistance in ICU, and some of the treatment, antimicrobials and other the medication that these patients have to receive when they have a positive diagnosis can be really toxic. So having a reliable result that is positive can guarantee that we have all the evidence and the case is clear for to start this process of journey of treatment for this patient. But if we also have a patient that has criteria but the test is negative, and if we have a reliable, highly specific and sensitive test, we can also guarantee that the patient will have the right treatment based on the reliable diagnosis. So that's also one of the reasons, one of your initial questions, why we actually bring the test in-house. Well, is to be able to reduce this gap from the moment that is a clinical suspicious of potential amoeba case to the point that we can have a clear laboratory diagnostic that it actually is a patient that is infected by a free-living amoeba. So reducing that gap is critical for survival of these patients.
That is great. Yes, and it's definitely, it is critical. So, well, thank you definitely for having this test is very important, especially here in Florida. So, thank you both for your time and your work for implementing this test. This is definitely beneficial for the patients, which at the end is what we do this for.
Yeah, and I mean the team in AdvenHealth, the whole laboratory team, Dustin leading that group right now, is why we've been able to do this. We are not a research facility. I mean, well, you know this very well. We are not a research facility, so we just do clinical work. But we've been accumulating a good amount of knowledge and skills, even before and during the pandemic, in the development of lab and the creation of lab developed tests. And the staff being able to get involved and do some additional research, do testing. So I think that is being the critical aspect to bring this test in-house. So there is facilities that probably have more resources and probably they don't have this type of tests implemented. But it's the human factor that make a big difference. So, and I think that's something important in the clinical laboratory field. Make sure that the scientist working in the laboratory is not only seen as a staff doing, a 10 or 12-hour shift, but also being involved in research opportunity, but also understanding and looking for solutions for those cases.
Yes, 100% agreed. Yes, it's definitely yeah, it is beneficial, for the growth, for the learning, and the more you get involved and learn about all these different aspects, it ultimately makes you better at what you do, because knowing all these different things, you go in and with more care, more taking your time to understand things better. Definitely, and I like what you said. Definitely there is a great team at AdvenHealth. I'm witness to that. So Dustin, thank you for your work.
Yeah, absolutely. It was a long time coming, like you said, since 2019 we started this validation. So we were really happy to finish it and have that test available for patients that may suffer from this disease.
Okay, well, once again, thank you, Dr. Alexander and Dustin, for taking the time to joining Let's Talk Micro to talk about this great test.
Yes, thank you for
Thank
having
you
us.
very much.
All right, my pleasure. And that, my dear audience, it's the end of this episode. I hope you enjoy learning about this amoeba test. As always, I enjoy sharing this information with you. So definitely this is a beneficial test to have. It can save lives, and that's what it's all about. So definitely for this 2023, I wish you all a healthy and happy year. Start it by bringing that passion to what you do. It makes you so much better at your job. So definitely continue bringing that motivation and that passion. It's so important. So, as always, stay motivated, stay safe, and of course, continue talking micro. It's so great to be back. Until the next time, bye